Hello everybody, this is Dr. Nurbat Shah from University of Engineering and Technology, Peshawar. Today this video is about inverse power method by using a calculator. How do we do that? Inverse power method, which is usually used for finding smallest eigenvalue of a matrix, and we can find corresponding eigenvector as well, smallest eigenvalue and corresponding eigenvector. At the beginning again, I will just explain how does it work. So let's suppose we have a matrix A. So for a given matrix A, assume that lambda is the smallest eigenvalue. And by definition of eigenvalue, there will be a non-zero vector x such that Ax is equal to lambda x. Keep in mind that the matrix will be non-singular. That is, determinant of A should not be same as 0. It means the matrix will not have a 0 or a 0 eigenvalue. Right. This can be written in this form as well. I just divide both sides by lambda and multiply by A inverse. So I'll just get lambda power minus 1 x is equal to A inverse into x. This basically means 1 over lambda, or we may write in this form, A inverse into x is equal to 1 over lambda x. This relation or this equation basically means that 1 over lambda is the smallest eigenvalue. So 1 over lambda will be the largest eigenvalue of A inverse. It means we need to find 1 over lambda, we need to apply power method on A inverse. It means, how does it work? For given initial value x0, we just select x0, which is a non-zero vector. We would find y, but this time we will be multiply A inverse with x0, and then we will find y mu1, which will be the numerically largest value of vector y. That means ym absolute will be the infinity norm of y. And then we normalize the vector y to find x1. So x1, that will be y divided by mu1. That will conclude again iteration number 1. Then we move towards second iteration. For the second iteration, we will find y again, which will be A inverse into x1 now, and then again you will find mu2. Mu2 will be the numerically largest value of y, and then we find x2. So x2, that will be normalizing y by mu2. That concludes second iteration, and so on. Once we have found mu k, so mu k will be basically the largest eigenvalue, which is 1 over lambda, but we will be interested in lambda. So lambda is what? That will be 1 over mu k. So 1 over mu k will be the smallest eigenvalue, whereas x k will be the corresponding eigenvector. Okay, so how does it work? Let me explain that through example. So let's suppose we are given this matrix A. Okay, this is our matrix A, and we want to find the smallest eigenvalue of this matrix. So the steps are similar as what we do usually in power method. So the first step is we have to go for matrix A in the calculator, and then we'll be finding to y when we multiply inverse of this matrix with this initial vector. Okay, so how would this work? When you multiply this matrix A with this one, inverse of this one with this, we get this quantity. Picking the largest value in this case is 0.9091, so this will be our mu1. Dividing this vector with this quantity to get this one, then multiply this with this matrix. The largest value is this one, which will be mu2. Normalizing give you x2. Multiplying this one again with A to get another largest value, this will be mu3, and so on. Once we are concluded this is the largest value in the seventh iteration, so this will be mu7, and then to find lambda smallest eigenvalue, it will be 1 over mu7. The eigenvector that would remain same, so 1 over mu7, that means 1 divided by 1.1467, which give you 0.8721. Now how would you do that by using calculator? The steps are very simple, because in this case we'll be only replacing mat A with the A inverse instead of that. Okay, so how do we do that by using calculator? A calculator must be in matrix mode, so first go to mode, then go to 6, right, and then it will ask about the matrix. So we just give matrix A to it, so press 1. We are looking for order 3 cross 3, so I'll just press 1, and then it give me the matrix this one, so I'll just input the matrix 10, already there, but I'll just repeat it. 10 2 7 1 1 1, then we have -1, then we have 1, then we have -3. Then press AC because this matrix is stored, and we have already stored this matrix mat B in it as well. Otherwise you can just find it again or input again, just 4, go to 2, and then get mat 2 again. So we have already mat 2 this one, so it's 3 1 and 1, then this one. So the next step in this case is what? You just go to shift 4 3, but we will be taking now inverse of it, so don't take power of it as a -1, it is the inverse. So using this key -1, and then multiplied by again 4, and then we go for 4 to get the product of these two matrices, which is obviously you see 0.1818, 0.9091, and minus, you see that we have it is 10 by 11, which is 0.9091, 0.909090, something like that. So we get minus 0.0909 as well. Okay, now dividing this by the largest value, in this case largest value is what? That is 0.9091. So dividing this by 0.9091, and then we press equal, you see it is this value, which is 1 here almost, and this is almost 0.2 something, and this is minus 0.1 as well, because we are dividing by a different value. We are not taking exactly the same value what we are having here. So next time we do is what? Multiply this by, from left side, by mat B inverse again. So just shift 4 and 3, but taking inverse of 3, mat A, and then pressing equal, we get minus 0.5773, and the next one is 1.0136 and 0.5636. The maximum value is again it's 1.0136, so dividing this by 1.0136, press equal to get this value. See, this is our first value, this is 1, this is 0.5561. Multiplied by, again multiplying from the left by inverse of mat A, so just shift 4 3, and then we take inverse of it, to guess the next, they get the next value. So that's the way to use calculator for finding smallest eigenvalue and corresponding eigenvector. So after 7 iteration, this will be the largest eigenvalue of A inverse, but we are interested to find smallest eigenvalue of A. So what would we do? We would simply take inverse of this one or reciprocal of this one, that is 1 divided by 1.1467 to get 0.8721, and corresponding eigenvector will be the last normalized vector. So that's the way to do it. I hope you understood it, and if you have any questions, simply just drop a message to me. I'll get back to you. Thank you very much for watching this video. Subscribe to my channel. Thank you. See you in next video.